Good afternoon, everyone. Welcome, everyone. Welcome. Thank you for joining us today. We have very good presentation today. So let's get started. Welcome, everyone. Thank you. So let me start by basically asking a question that it's a rhetorical question, but I'm pretty sure that everyone here has heard before about AI agents. With the revolution of AI, we have created so many new concepts and so much new technology. So the question is really, what is an AI agent? What does it do? How is it different than a regular chatbot, or what's special about it, right? So in today's presentation, we we are going to cover all the details, and by the end of the presentation you will be able to understand clearly what an AI agent is and how to go about to build one using different technologies, right? Using some of the expertise that we already have, but we're just introducing a concept, a sort of a design pattern and methodology to build AI agents. So welcome. My name is Oscar Garcia. So thank you for being here today. My expertise are around building out application using cloud, web, AI technologies. I'm also an author. I published a book called Data Engineering Process Fundamentals that basically has a focus on how to build data pipelines and data solutions. You have a QR code there that you can scan to get links about the presentation materials and other GitHub's repos that are available that cover different aspects of data engineering, web, and AI. But in today's presentation, we are actually focusing on AI agents and what is it? What are they, right? It's really, to simplify, is a software robot, right? It's a bot that has the ability to observe what's happening, and it can figure out what to do and take an action, all without having a human guiding it, or all without really generating the code to do that. So if you remember, when we build solutions, right, we build all this code to be able to say, if a certain condition is this, execute this, and so on, right? So an agent has the ability to sort of figure that out based on observations. So basically, we're going to talk about an example, for example, to make it more concrete. Let's say we are at a manufacturing setting. If you're not familiar with that, just basically understand that there's a lot of data flowing in a manufacturing plant where they're building CPUs or whatever other products, right? But the focus there is that there's a lot of sensor data that is produced in real time, right? And there are so many processes out there to be able to measure what's going on. They use something called control limits. And what that really is just kind of monitors the process and makes sure that there is no data anomalies that are causing for the process to fail or to introduce defects into the products. So the idea here is that a bot can be used for those scenarios where it can actually look at this information and actually decide whether an action is to be taken, to flag a particular process and to raise some kind of output to be able to act on that decision making, and be able to say, we need to shut down the plant, we need to shut down the process, we need to notify support or the QA team to be able to take an action. So if you look at that diagram, basically, that's a very simple view of what an agent is. So if you kind of look at it, it's sort of a workflow, but it's a smart workflow. You can actually use models, AI models, to be able to figure a lot of these things. So basically, AI is pretty good at understanding data, is pretty good at understanding certain prompts that enables the agent to be able to understand what it needs to do. So for example, monitor this real-time data, or if something happens, execute this action. But how does it really do it, right? How does it know to be able to understand what is this data, what are the rules that govern this process, and how does it take an action, right? How does it do that? How does it know that? I mean, is it different than just an automation where we can actually just connect the nodes and be able to say, if this condition is met, do this? I mean, what is the big difference? So basically, what makes it different is that the concept of autonomy, right? So basically, comparing to a traditional automation process where we actually connect links and we are actually saying, if it is this condition, do this step, and so on, right? In this case, we kind of just explain, we sort of provide the specifications for the agent to be able to be aware of what it needs to do, right? And to judge, to understand what it needs to do, and then take an action. So the three main concepts of an agent is really perception, reasoning, and action, right? So perception is really understanding that there's some input. This input could be telemetry in real time that enables it to understand what type of data is flowing, right? The reasoning piece is what makes it smart, right? The reasoning aspect is what it enables it to understand trends, patterns, and be able to say, oh, if I'm actually, if I need to understand what a control chart is, I sort of understand the foundational concepts of that, and so I need to monitor this data and react to it, right? So that's the secret sauce, so to speak, right? That's really the magic of reasoning for an agent. And what does it use for that is the big question, right? And an action also, right? Once it understands there's something going on with this data and I need to take action, then the question is, how do we take an action, right? If you have done systems like this, you know, you got to call an API, or you have to send an email, or you have to send a text message. You have to do something with it, right? So you programmatically need to go ahead and just create that logic and be able to fire that API. But how does an agent know that, right? How is he capable of saying, I need to send an API or an email, and how are we doing this if we're not really coding it? How does it figure? What makes it be able to understand this? So that is the secret power, right? That's the what makes it autonomous, is the ability to be able to do this on, to observe, think, and act. But what are the core technologies that drive this behavior? Right. So for perception, we need to be able to the agent needs to be able to get that data, understand that data, sort of figure out what's the purpose of that data, and kind of have memory, right? And the memory is for understanding um, previous events, right? So for example, in certain use cases, you need to understand not just the data now, but how the data is trending, right? So you need to sort of have a snapshot of the last 5, 7, 10 readings and be able to create a trend and understand how to build this trend based on past data. So it needs to have memory and track this information. But then the true smarts of it is really using AI models, right? Large language models like Gemini, like OpenAI, like Llama, to be able to sort of understand the magic of this is data that is meant to be used for control charts. For example, if you're not familiar with control charts, basically there is the concept of control limits where you cannot go beyond those boundaries, right? So if you have a data reading that exceeds or goes below those boundaries, that signifies, or that tells you that the process is going out of control, and that's not good in manufacturing. Okay, so and then in addition to using these large language models, it also needs to execute some tool. And the tool is a database. It could be an API, it could be an email, But how does it do that, right? What is it? How do you, I mean, we introduced the concept of MCP tools right now. Um, and what is that, first of all? And how does it, I mean, if you think about it, how do I call an API? I mean, usually I need to sort of look at the API specifications, right, and be able to wire that RESTful request and be able to send it, right? Or if it is an email, I need to sort of have an understanding on how that works. So what are these tools? How does it know? And what is MCP? So MCP stands for Model Context Protocol, and it's really the magic behind tool integration, right? So it is really a communication framework. And just basically it allows the tools to sort of discover things like APIs, databases, or whatever other system an agent needs to integrate with, right? So if you're familiar with an API, so for example, let's take an example, right? Let's say the agent needs to notify, hey, I need to notify that there is a vibration spike detected on a particular uh, device, right? So the action of that agent is to be able to say, send this notification based on this threshold violation. So usually what we call an API, like you see there on the screen, right? But how does the agent will know how to call that and send that API? So basically what it does, it just looks at the tool metadata. So this is sort of a protocol at that point, right? Where you actually need to provide all this metadata so the agent can discover that. So it will just look at the tool parameters, examples, and sort of execution specifications to be able to know that this is a webhook or API and that I need to send a request with these parameters, right? So this is the sort of metadata that the agent will read. But how does it do that, right? How does that, well, it is exposed by the tool because it's part of this protocol. MCP is sort of your communication protocol that the agent uses to be able to say, a tool, what do you have? And this that you see, this metadata that is there is sort of a prompt, right? So the agent reads this metadata as a prompt and is able to understand all the specifications for that tool. So now it understands that, hey, I have this tool and I'll be able to use it to send notifications. So now it just did the discovery. It knows the tool is there for that purpose. But how does it know now that when you send a notification, use the notify supervisor tool, for example? How does that work, right? How does it understand this MCP and how does it perform? How does it do that action? So so how does it understand MCP? So it's not like a function call like we do an API call, or we use an SDK or something like that, right? It's just basically it's all AI driven. And what that means is if you've ever done chatbots, you kind of need to declare an intent. And that intent basically saying I would like to do this. So the agent declares that intent, and the NCP um, basically then translates that into an action. And that's where the magic is. MCP is this new communication protocol that enables us to make this agent autonomous in that sense, that it can use tools without us having to program or without someone doing it manually, of course. That's the whole essence of this. So basically, it reads this tool metadata as a prompt, and then the agent emits this intent with an MCP syntax, of course, like for example, notify supervisor alert and send the message in the payload, right? And basically at that point, MCP matches this to the tool that is registered and is able to understand the specifications of this is an API call and I need to execute this action on that API call. So therefore, the engine basically does this HTTP request, uses a URL, and any type of authentication or headers that are needed for you to be able to access that tool. Therefore, the request is sent, and the notification is sent towards the team that needs to basically get it. You can do more things than that, right? You could access a database, you could trigger workflows, you can do all kinds of things. You can send the message to another agent that can do maybe some kind of escalation logic. You can do anything at that point. Is abstract, right? It's just another tool that is able to handle the request from the agent. So basically the agent only describes what's happening, and MCP handles the actual execution of that. But how, right? It is not clear yet. How does it do that? How does the agent knows that it needs to declare an intent for that tool to be able to be used, right? And that's where the magic or the use of prompts come in. So if you're familiar with prompts, right? Prompts is what we use to be able to tell the AI what to do. But maybe you are not familiar with new concepts, in the sense that there is what we call system prompts that are way different than the user prompts. Essentially, they're just prompts, but basically agents are designed to be able to understand system prompts in a way that you indicate to the system the identity, the purpose, the reasoning and strategy. So for example, we can tell the agent, hey, you are a manufacturing agent, that you're specialized on SPC rules, control charts, and when you get data, do the analysis for this data, and make sure that if the thresholds are above or below limits, send a notification to a tool name manager notification or supervisor notification. You sort of express all this in words. So now the agent knows, this is my role. These are the tools I have available. I can use a database or an email or an API, and I can just use that. And this is something that is basically well defined into the agent, and it does not change. This is really how you build the identity of that agent. But then we have the user prompts, and that is really what's dynamic, right? So the user prompt really tells the agent, hey, I'm going to send you a payload of data. Can you check if I need to make an adjustment to my process? Can you tell me if the trends of the data flow is going to, there's going to be failures, or help me out, right? That's where the user actually is providing the information to the agent, to be able for the agent to reason based on what the user is asking. And of course, the LLMs, the model, the AI agent, AI model knows all of this, knows how to interpret data, knows how to look for trending information, for um, out of control conditions in the data set and all that. That's where the large language models are good at, because they have been trained on tons of data to sort of understand these specifications, right? So for example, the person just says, hey, please analyze this for me. Okay, so that's basically the core difference here, that there is a system prompt and a user prompt to be able to sort of give the agent an identity and have the user be able to do or get feedback from the agent, right? So how do we get started, right? So we sort of have now sort of a foundational principle on how agents are different than just basically a chatbot or something like that. Because if you don't chatbots, there's that sort of still very hard-coded path, right? If you ever wire them, you provide an intent, and then you tell a chatbot, hey, from this intent, you can follow this path. And if they take that path, then you can return this. We don't wire agents like that. Agents are completely more autonomous, in the sense that you don't really pre-build a script. You sort of just give it an identity and some of the specifications on how to behave, and it will interpret the data, and it'll have a dynamic understanding of what to do. So how do we go about this? I mean, there's tons of tools out there, and there's so many frameworks and libraries that are available. There are many, like, we have OpenAI, Gemini, Llama, to name a few, and we have so many frameworks. But in this case, we have to focus on something, right? So we're gonna focus on LangChain and LangGraph. And if you're not familiar with that, just basically what they do is they provide you with libraries that enable you to integrate with any kind of AI model, right? So it's agnostic to that, which is great. That way you can switch from one to the other. And it also provides support for integrating with tools, um, support memory, use vector databases, use API. So it gives us everything that if let's say, for example, I want to integrate directly with Gemini or OpenAI. I mean, the amount of code that I have to do to create all these integration points is huge. And that's not where I want to focus on, right? I want to focus just on sort of building an agent and give that agent an identity, right? And I want to have that focus. So I can use that or LangChain, or I can use LangGraph, which is a more powerful orchestration library that enables us to it uses LangChain as a core library, but it enhances that by using orchestration, right? And orchestration is what gives the AI agent the ability to be able to say, I get an input and I can use this language model, and I can use this memory tool, and I can use this API, and so on, right? It gives that orchestration, it gives that ability to be able to act on the workflow and maintain state. So it builds something pretty quickly for us ahead of time, right? And you have other things for building, deploying that you can use. There are also no code frameworks like N8N, which is a no code orchestration platform that lets you build, wire agents, deploy, and host them, or you can host the agents yourself, right? So, all right, so let's take a look at that. Enough of that conversation. Let's just take a look at something, some code, and be able to show you. So basically, I on the chat, if you take a look at the chat, I send the GitHub repo for this, and I'll take you there pretty quick. So if you visit this GitHub repo that you see here, so basically we have AI projects in there, and you will find that there is a AI agent folder in there. And that's where we actually do some of these projects. So you are welcome to take a look, see how that works, and be able to use it. But okay, so this is the AI agent folder. We continue to grow this project, so please follow the project. Just give it a start, and we continue to grow it and add additional stuff to it. So anyway, so this is where you'll the stuff we're gonna look at right now. We can see, we can find in this repo. So let's go ahead. Let's take a look at the actual code now. So I hope the screen is big enough. Just say yes or no if you can see it. Can you see the screen pretty well? On the chat. Thank you. Thank you, Javier. Frederick, thank you. All right. So this is the GitHub repo, right? It's just loaded on Visual Studio Code. And now here you can see the AI agent project. So what I'm gonna do, because we don't have a lot of time, but I'm just gonna, if you can look at this Jupyter Notebooks files, which is, I'm using Python for this, but you can use TypeScript, the same with these libraries, right? So what you're gonna see here in this format really is you're gonna be able to actually see some instructions how to build this out. What are the dependencies that you need to use? And don't focus too much on whether it's Python or JavaScript, right? That's not the purpose. Just it's the concepts of how to use this library. Then you can just pivot to whatever language or whatever libraries you prefer to use, and whatever AI models you prefer to use, and use those, right? But in addition to that, here you will see other projects for using use cases like building, generating code, understanding charts. I have other presentations, some other areas that you can take a look. But anyways, let's focus on this. So how do we build this agent, right? So our goal here is to build an agent that works for a manufacturing set. In a manufacturing setting, we want to be able for this agent to understand that there's going to be data that's going to come in real time, right? And that data looks like this, right? The data looks like this. It's a sensor. It's a telemetry data that comes from sensors, and it sends to us data points that indicate certain conditions. So, for example, you will see something like UCL, LCL, that's upper conditions limits and lower condition limits. And what that just means is a window, right? If you go beyond the 90, you're going out of control. If you go below the 50, you're going out of control, because the data tells us that the process is within control limits, meaning the quality is maintained. And that's just basically a rule for manufacturing, right? You're sampling data and be able to understand that the material you're building is actually of high quality and it's not going to fail. So basically here, what we do now with that in mind, that we understand that's the we want to be able to do, we're going to use a land graph to build this out. And basically some of the boilerplate here is really just go ahead and what information for, use PIP environment to create a virtual environment in Python. You don't have to, but you could do it. And basically install the dependencies. Okay, so, and this is just information on dependency checking, because Python, PIP, NPM, there's the constraint, there's a lot of constraints on what versions to install and so on based on the libraries you want to use. So these are just utilities to be able to see what versions we have. Okay, but anyway, so the first thing you need to do is we're going to use Gemini as our large language model. You can use anything, Llama, OpenAI, what have you, but you will need a key, right? You need a key to be able to access the resource. But what we need first is, once we get that key, and that key we're just loading from an environment setting, so we don't have to look at it and understand what the key looks like. We basically create a definition for a Gemini chat model, right? And this is the large language model we're going to use. And we're using Gemini 2.0 Flash, right? And you can use others, right? There's tons of models that you can use. But we're just choosing that. It's a lightweight model. It's not as expensive when it comes to the tokens and so on, right? And we're trying to be very deterministic. So temperature 0.3, we're saying, a model, when you give us an answer, be accurate. Try to be accurate. Don't just give us some random stuff that makes no sense, right? So, but how do we give that character, that identity to our agent, right? How do we do that? So the thing is, we need to give it a system prompt, and that is basically where we're specialized on saying, you are this type of AI. Your job is to do this. You need to assess if the data is going out of control or not. You need to be able to ignore certain things, for example, if you want to, but we want you to act on with the following, right? Observe the data with the new readings, or whatever else you're trying to do. Observe something. You're actually telling it, observe this. And I want you to reason. I want you to explain the status of the data, the trend of the data. And that's where memory comes in, right? How is the data trending? Right? And give me some SPC rule violations, right? And that's where the models, Gemini, OpenAI, whatever, they're very good at understanding these things, right? They understand that when you say SPC and understand the context of the data, it definitely knows what you're talking about. But we can expand on this and give it even more information, right? And then we tell it to act, right? Send an alert to the supervisor, do a prep for shutdown, monitor. So all this could be tools that you're actually tagging and saying, do this, right? And what's going to do is whatever the output is, it'll be able to do that. So for example, if we say send an alert, it will just send whatever the analysis of the data is. If we say prep a shutdown, it will probably say, okay, what is the tool for my shutdown and what does it require me to send? And that's where the the integration with the tools will work and discover how to call it and how to use it. But then we have a sample input, right? So it's a sensor data as we saw it here. It's just one simple sample. And we're saying this is what's going to come in. But of course, in a real environment, this is coming every hundreds per second, if not more. But the idea is this data is coming in, right? So the agent will be able to sort of understand and maintain a window of information, maybe the last 10, 20 requests, because depending on your process, right? In your process, anything that's over 10 minutes is useless, right? That's too late. You don't care. It's irrelevant. For historical purposes and reporting, yes. But for real-time monitor, it is too late. So you don't care. You just need to have a small window so you can react right away. So how LangGraph agent workflow works. So remember, so we have Lang chain, right? Which you can, and there is a project here also for that, and you can take a look at how that works. It just basically does the same thing, but it requires a little bit more coding because it doesn't have all the features. But you can look at it and see how that works. So, but the upgrade really is using Graph. And why? Because you're able to workflows. You're able to say, I want to be able to ingest data, analyze data, have an action on that. So that is basically how this will work. So in our sample here and our demo that we're using, basically, we are saying basically, hey, okay, so we're gonna be able to create this workflow definition to ingest the data, right? And we give it some understanding of what the data is. We analyze the data, right? We analyze and we give the rules from the prompt to observe, reason, and act, and then an output step, right, to be able to do something with it. So the way to visualize this is what's going to happen is once we actually build this workflow, this graph, this is what it looks like, right? And if you go back to the beginning, I sort of gave you a picture of an agent at the very beginning of the presentation. So you can sort of correlate this information to that, right? It's building a workflow where you can do several things. But in the terms of LangGraph, what we're doing is we're just sort of building that out through code, right? So here we just have some utilities to be able to in this case, we're just going to show the response of the agent, right? That's all we're going to do. And we're going to look at the analysis of the AI and be able to understand what it's telling us, right? When it comes to all those aspects of observing, reasoning, and acting. Right. So basically, it's going to say, hey, I got a new data point that is trending, is violating the upper limit conditions. We need to shut down the basically what that will do. Right. So now we're going to start building our agent. Right. So we're going to build our agent. We're going to say, hey, first of all, let's create a schema definition of what the agent behavior should be. And so it can maintain the state of the agent. So remember, memory, right? So we need to give it memory so it knows how to keep track of previous interactions, previous data, input data fields or data points, and be able to understand trending conditions, right? Hey, I had a reading and I see from the last 5 readings, we're going out of bounds. We're going over the limit. So it will understand and reason that there is a problem. So it doesn't only focus on the one single data point, but it focus on the whole data set, that the window of memory that it has. Then we just create a node for the ingest, right? The ingest basically what it does, agent state, and it actually knows that there's a new data, sensor data that came in, and it knows how to consume that and add it to the state, basically. So this is doing sort of the state management for that. And then the analyze step is basically saying, okay, So I get this data. Okay, so I'm building out my message and I'm building my intent and I'm invoking my large language model to be able to do the analysis. So here basically is where the magic for the uh, reasoning piece works, right? This is where it's actually saying, I have a system message and I'm actually also have this human message, right? And it's going to combine the two, and it's going to be able to then invoke that to using the large language model and be able to say, hey, tell me what's going on, right? And it's going to get that response, and based on that response it'll be able to act upon it, right? It could just be, hey, this is my analysis, or it could be, I need to take an action, you know, or in both actually, because it's going to get the analysis and it's going to do an action. What you're going to notice here is that we don't have, we in the output, we're just basically showing the output process based on that state, but we're not really taking an action. We're really not wired to a tool, right? But that could be another node. So when we're building these nodes here, we can actually go ahead and wire tools to be able to do the output. So here we're not going to do that. In the next example, I'll show you how to do that tool. Okay, so but understand. So you have the code there. You can take more time and read it and understand all of this. So basically, how we build a graph, right? So we say we're building these nodes, right? And we're defining these edges, which is really the connections between nodes, so he knows how to move in the process. So it's just building that blueprint for the understanding, right? And we compile and run the agent. So the agent now is live, is running, is just waiting. Sensor data comes in, and this is just example of how data is coming in. And it's saying, I'm ingesting the data, and this is the data point, is analyzing it using the large language models, and it's saying, hey, I have a vibration reading of 89 for this motor, and the current reading is within UCL and LCL, right? But it's saying that the previous two readings in the trend window, 94 and 86, show a downward trend, right? So, and the current value is close to UC. So it's actually telling us now, when it comes to, if you understand this history, it's just basically saying, I'm looking at it right now. You are within limits. However, I'm seeing tendencies, trends that this may not be good. And that's a big warning for a manufacturing process. When you start seeing tendencies of going out of control, that something is up, and you don't wait until it completely crashes. You basically just stop the process if you're trending. So usually they'll give it 2 or 3 data points that say, hey, you got 2 to 3 in a row that are completely trending out of control, or 2 or 3 that are completely up and down, right? They're not showing a linear trend. There's something going on, because it's very unstable process. So that's basically what that means. So then you have the final output, the agent response, and you get this is like a normal AI will respond, right? With all the details of the information. But that's really a very simplified way of building using that library, of course, an agent. However, if you just go and try to use, for example, a model like Gemini or Llama, you have a lot more code also. But what if I don't want to use code, right? Because right now this is exploding everywhere. A lot of people are just going with no code platforms because they want to build something today, right? What do I use? So you can use frameworks like and or services, I should say, platforms like N8N, and they're just basically a no-code platform that enables you to build agents. So to show you an example here, this is the screen we saw. This is the agent we saw at the beginning of the presentation. So this is a no-code platform. But what you can see here is, if you're wondering, right, you're thinking, okay, so what is this, right? We have a node. We can see nodes here for the agent. We can see nodes for the model, AI model. We see node here for simple memory, right? We see a node here for a chat message, or whatever is that pipeline where the data is flowing. and we see the edges, right? So these are the connecting points, and that's what you see. But how do we configure this? Of course, you configure your model by providing your credentials, just like we do anything, right? You provide your credentials, you configure your login, you give it a credential so it knows how to use it. Simple memory is just in memory, but this could be a database, could be some kind of Redis in memory, cache. It could be anything, right? But then the magic of the agent, what is the agent, right? And how do we compare that to how we build our other agent through code, right? So if you open this agent definition, really, this is where you actually can tell your agent things like, for example, what is your personality, right? What is your identity? So you have the concept of that system message that we talked about, right? So this is the system message, and this is where we're actually saying all these things, right? You are a specialized control chart that monitors this, and this is where we're actually configuring the identity of the agent, and we're giving it the entire what to do, the specifications of how to behave, right? So this is your system prompt, basically, right? And then we have here is the user prompt, and in the user prompt we're using input fields to say, hey, new telemetry data from previous nodes. And this is where we are sort of configuring the fact that we're saying whatever comes in through that channel, which is that chat input channel, this is your telemetry data, use that, and then run and execute your analysis, right? So in this one is not wired to a tool, but let's say you were actually wired to a tool, right? So I'll show you quickly. If you're wired to a tool, let's say, for example, an email, so you could use something like this, right? And in this case, we can see that this tool enables us to send, integrate with the, I'm sorry, this agent can integrate with Google Sheets. It can send emails, and it can do that. But how is this magic, right? If you think about it, how is this magic? And I'll show you just really quick what this manufacturing agent looks like behind the scenes. So we saw the visual there, right? But how do they build these things, right? If you look at it here, you will see this. You see that? You see what they're using here? They're using LangChain components to build this. So they're orchestrating all of this using LangChain to be able to build this, because the framework enables you to build this. All they're doing is providing a nice UI interface to be able to show you something that looks like this. But that's really where the magic is happening. All right, so that was a lot of data, a lot of information that we packed, but we got to our conclusion. So thank you. If you have any questions, we can take a couple of minutes. If not, I really appreciate you joining us. And by the way, let me plug in my book. Take a look at that book. It's available on Amazon if you want to learn more about data engineering. And also it's backed by a GitHub repo, so you can do that. Some housekeeping notes. Everything you have seen, the presentation material, the videos, this is being recorded. It'll be available. I'll send an email communication in the community. So you'll get a link to YouTube video and the presentation material, so you can just review and take a look at the GitHub project, play with it. So it's important to now you go back, read it, understand it. I gave you a lot of information. I was going too fast, but now you have some of the fundamentals. Now you can go right ahead, go back, and be able to review this at home and be able to kind of understand this clearly. But I really thank you for joining me, and I hope that you have a good rest of the day. Any questions? If no questions, thank you so much, everyone. Thank you for joining me. Okay, thanks.